So once again, members, good afternoon and welcome to our meeting this evening. I want us to have a look at lab practical exercise number 2 and number 3. And we're going to undertake this particular practical lab exercise by using the RapidMiner Studio software. This is a 2-in-1 lab practical exercise. And of course, even in terms of the report that we'll be writing, it will be a considerably lengthy report because it is a 2-in-1 report. It is entailing lab practical exercise number 2, as well as lab practical exercise number 3. By the end of our meeting for this particular lab practical exercise, you will be very comfortable with what should be done in the lab exercise. We have a couple of objectives that are ahead of us in this particular lab practical exercise. The first objective is I would want us to understand how to perform the following one: load data into RapidMiner Studio environment, select a task to perform, prepare the target, make selections from the inputs or for the inputs, determine which type of the model to use, run the results, and of course, be able to view or access those results. So the first objective is loaded with a number of activities, from loading the data, selecting the inputs, selecting the model, to running the results. Specific objective number 2 that I would expect us to also learn from this lab practical exercise is practice with the data science processes. So there are a number of blocks, of course, processes which we're going to have a look at. And I would want that we also acquaint ourselves with the functions or the roles that are performed by different blocks. If it is a retrieve block, what does it do? The set role block, the optimize parameters block, the filter examples block, the select attributes block, the apply model block, and so on and so forth. Okay, so I would want us to practice with the data science processes. 3, I would want us to practice with different data science models. Of course, these are artificial intelligence-based models, okay? Like the generalized linear model with or without regularization. There is the deep learning model. There is the decision tree model with and without automatic optimization. And there is the support vector machine with and without automatic optimization. I'm not saying that these are the only data science models which are available under the RapidMiner Studio environment. No, there are other models which are available there, but we have just selected a few of them to use in the lab practical exercise at hand. And we will also try and compare the results coming from these different models. Remember, there are some models which are good in carrying out prediction. There are some which are good in carrying out classification, and so on and so forth. That is the reason as to why you see the title of the lab exercise is also loaded, because this lab exercise is about data processing, which is a topic we had already done, modeling, which we had already done, classification, which we are yet to do. Actually, classification will be the last topic that we will cover. And remember that when we meet next week, we will be having Cut 2 and also our final meeting. So the meeting we will have on Thursday, this week, and the meeting we will have next week, Thursday, will be the final meeting. So remember, we are completing everything next week. That's why I also needed this makeup, okay? I needed this makeup just to ensure that we will be finishing everything by next week. So when we meet this week on Thursday, we will be meeting for theory. And then next week, we will meet for Cut 2 and also finish up the small part of theory that will be remaining in the event that we will not finish, in case we won't finish theory on Thursday this week. So there's the classification which we are yet to do, and then there is the visualizations topic which we did last week on Thursday. The 4th specific objective is appreciate different data visualization methods Okay, this one we did last week theoretically. So of course, we're going to do it also practically today. And then the last one, to undertake a case study on data analysis with a credit risk data set. So we're going to look at the credit risk data set, where we are going to look at a company or an organization called the counterparty. So we will assume that this organization or company by the name counterparty has got some risk data. This risk data is basically data containing the attributes of firms and the past default of observations. You know, when you lend people money, not all of them will pay, isn't it? When you lend people money, it is true that not all of them will pay. Some of them will not be able to pay, maybe out of the circumstances beyond their control, isn't it? But definitely when you lend people money, it is difficult it will be far from reality, expecting 100% repayment. But you see, these bad debts and defaults, those ones represent loss of revenue to the organization. And if they're on the higher side, instead of making profit from the loans or the credit facilities, the bank or the financial entity or corporation will end up making losses. But what if you have a model that can then now help you know who to lend, how much to lend, and for how long, without actually taking risks with the actual customers? You see, you can easily then plan on how the business can succeed. Are you getting the point? Good, good.
Yes.
Good, good. So the introduction part, which is sometimes called the theory, that one you can get the information from the lecture notes. And then the tools, materials, or software. We are using the RapidMiner Studio as a software. Laptop is the device we are using, and ensure that it has got the operating system and the Microsoft Office processes. Then I come to methodology, which sometimes are also called procedure. In your report, you have to put this one in past tense. You have to put the steps or the procedure here, you have to put into past tense in your report, okay? Okay, like you say, we began the lab practical exercise by starting the RapidMiner Studio. Then we went to file and selected new process. Then we selected choose a template to start from, and then went to credit risk modeling. So let's do those ones quickly. So let me start my RapidMiner Studio. Let me start my RapidMiner Studio application. In the meantime, we can type our names and admission numbers on the chat area there for purposes of taking the attendance. So I'm starting my RapidMiner Studio. I'm starting my RapidMiner Studio software. It's coming on. I'm starting the RapidMiner Studio software. It's coming on. It's usually a slightly heavy software. You have to be patient with it. Okay, maybe as it is coming on, we can continue. Then present a screenshot of the model and explain briefly what each block achieves. And I've given a screenshot of a typical screenshot in figure number 2, but I would want you to take one from your own model. Okay, so figure number 2, this one here. Okay, this is now what we are looking from the RapidMiner Studio. Okay, so this is what we want to access. Okay, so like here, I expect you to tell me the sorry about that. I expect you to tell me the function of the retrieve block, the set roll block, the filter examples, and each and every block that is appearing here. Like if it is the apply model block, you also have to tell me the function. And I will also give you a shorter way of obtaining theoretical information about each block and getting to quickly know what each block does. So let me go back to the RapidMiner Studio software. I've gone to RapidMiner Studio Software. I'm not sure whether it is visible from your end. Is the RapidMiner Studio visible from your end?
Yes.
Yes, good. So either you can come and click this credit risk modeling, or you can just close this dialog and then you come to file, then you go to new process. So you click new process, and then you see when you click new process, then this dialog box will appear. Okay, you know, sometimes it can appear automatically when you start the RapidMiner Studio, but in certain instances it may fail to appear. So if it doesn't appear, if it doesn't appear on its own, you just go to the file, you click new process, then it appears. Now, once it appears, in our case here, we are doing a financial risk modeling or credit risk modeling. So we can come here, okay? Like here it is said, model credit default risk by training an optimized support vector machine model. But for us, we will not work only with the support vector machine model. We will also deploy other models. So you click on that. When you click on that, it will display this. Are you seeing the model? Are you seeing the model? This is the one whose screenshot, yes, this is the one whose screenshot you need to present. That is the one whose screenshot you need to present. So every block, remember, I'm expecting that you give me the function of every block. To know what the every block does, I will show you, but I can quickly run members through. We use the retrieve block to load data. We use the retrieve block to load data. Then we use the set role block to specify what is it that you want to do, or what is it that should be predicted. Then we come to the block for filter examples. We usually use it as a data wrangling block. Like you can filter maybe which range of data you want to work with. So that is the data pre-processing block. Even the select attributes is the data pre-processing block. Sometimes we say edit, transform, and load. Okay. So this one is part of data pre-processing. Okay. Then optimize parameters. We usually use this block as a means of specifying which of the parameters we want to optimize using the model. Okay, so that whatever we are feeding to the model are parameters which we have already specified. What is it that should be optimized? Then apply the model. This is the one that allows us to select which model we want to use. Like, is it maybe artificial neural network model, support vector machine model, the K and N model, if it is maybe generalized linear model, and so on and so forth. So the model, and there are many, I will show members, there are many. The model you want to use or the model you want to apply is selected by using this block, okay? Then if you want to log data, you will use this block here for logging data, okay? So you have been given the steps that we need to follow here. Like if you look at this block, the first block here, or the first step here is to load the data. And this is financial risk data or credit risk data. Of course, that is coming from a company called the Counterparty. So we call it Counterparty risk data. And it has got the attributes of firms as well as the past default observations. So you load that data, okay? And then after loading the data, you may find, of course, also that maybe there could be some data that is missing, or there are some firms whose data you don't have. Okay, so in that case, maybe for the firms where default observation is not available, we had already looked at in class how we deal with missing information. So you can invoke that. Like you can predict, you can choose to ignore, okay, and so on and so forth. We had already seen how we deal with missing data. Then in step number 2, which is data pre-processing and wrangling, you edit, transform, and load the data. For example, you can split the data into 2 rows, okay? There is a row which has got a level value, so it is known to us but there is another row which doesn't have the label value, so we don't know it. The row which doesn't have the label value is the one we want to predict by using the row which already has the label values. In step number 3 down here, we can use the optimized parameters to train and optimize the support vector machine model so that we can predict the credit risk. But we may not necessarily use the support vector machine only. As you can see, or as you're going to appreciate in this particular lab exercise, we are also going to use other models, okay? Other models. The support vector machine as an artificial intelligence algorithm or approach is usually created on the basis of 2 important factors. These parameters or factors are usually adjusted during training. The first parameter is called C, and the other parameter is called gamma. So when you adjust the values of C and gamma properly, you will end up with a model that is efficient enough to allow you make accurate predictions. Then the apply model here, you can now use the optimized the optimized support vector machine model or any other model to carry out the prediction of the likelihood of someone defaulting when they are borrowed money. Okay, when they are borrowed money. And of course, I will also show how you can select what other models. Remember that another input to the model to be applied is the parameters which are to be optimized here. Okay. And then, of course, there's the attributes selected. So those 2 will be the inputs to the apply model block. The outputs here will be optimization log, the performance of the best model, and the default predictions and the confidences. Okay. So basically, that is what we have. If you come to the lab practical exercise, we've already gone up to here. We've already gone up to number 4, where I had asked you to present a screenshot of the model and then we explain briefly what each block achieves. Perhaps if you need detailed information on every block, like if you need for retrieve, you just right click. Are you seeing this one of show operator information? Are you seeing that? You click. Okay. Then when you click, then you come to description. You click description. Okay. So you will be told what the block does. You'll be told what the block does. Like here, you'll be told the retrieve operator loads a rapid minor object into the process. This object is often an example set. Okay. But it can also be a collection or a model. Retrieving data this way also provides the metadata of the rapid minor object. Or up here, you'll be told in summary, this operator can access stored information in the repository and load them into the process. Have you seen that? Let's say if it is this block that you wanted to find out information, just come right click, you come to show information. Then you come to description. This operator finds the optimal values of the selected parameters for the operators in its what? Sub-process. And then the details are given there, okay? So this is what I like about Rapid Miner Studio, something that is not easy to come by in other data science softwares, okay? This is a software which has got all its theory on board, okay? If you want to know like what the filter examples does, you just come to show information, then description. This operator selects which examples of an example set are kept and which examples are removed. If you come like here, you go to show information, description. This operator applies a model on the example set. Okay, if you come to log to data, you go to show information, description. This operator transforms the data generated by the log operator into an example set, which can then be used by other operators of the process. So members, have you seen how you can get theoretical information to discuss or explain the function of each block? That is what I'm asking from here. Explain briefly what each block achieves. Are you now comfortable with that? Are we comfortable with that?
Yes.
Okay, good. The next item we've been told, run the process model by clicking the blue icon, which is under connections in the main toolbar. Under views menu at the top, click results, which is between the design and turbo prep windows. Provide and explain each. Okay. Each of the screenshots of the following areas under results: data, statistics, and visualizations. Hint, just click each of them from the left menu, while under results, window? See figures 3 to 5. From the data visualization area, provide and explain the following plots. Maybe let me run members through number 5 and number 6 first. Let me run members through number 5 and number 6 first before we do what? Before we do number 7. So let's do number 5 and number 6 first. So I can go back to the software. Then we were told to click the blue icon, this blue icon below connections. So you click on this running, 40% model is running, model. Okay, we are done with running the model. Now, after running the model, we have been told to go to results. Okay, we've been told to go to results. Now, when we go to results, I expect you to also present the screenshots. Okay. Now, there are some situations whereby even after extending, you will find that your data is, you are not able to display the entire data on the screen. If that is the case, just take a portion of part of the data that is visible, okay? Just take a portion of part of what? Part of the data, okay? Just take a portion of what? Part of the data. Now, like filter examples here, if you click on this drop down, you see here I've put all. If you want only the data with no missing attributes, you set that. With the missing attributes, you check that. No missing levels, you check that. Missing levels, you check that. Here we've selected all. So this is under the data, okay? And this is the data that the financial risk model or data analysis setup is dealing with. Can I show you where this data is obtained from? This data, if you want to see where the data is, just come to design here and then double click on this retrieve block. So when you double click on the retrieve block, you see it is the counterparty risk data. You know, when you go to the RapidMiner studio repository, there's training resources, community samples, local repository, temporary repository, and the database. Of course, the legacy database. Okay. Now you come to samples here, double click on samples. Then you come to, under the templates, we had gone for credit risk modeling because that's what we are doing. But you can also do predictive maintenance, price risk clustering, web analytics. You can do market basket analysis, medical fraud detection, outlier detection, and so on and so forth. So, or even direct marketing. For us, what we are doing is credit risk analysis. So you double click on that. When you double click on that, you'll see the counterparty risk data is there. That is the counterparty risk data, okay? The number of examples there are 424, sorry, and the number of attributes are 20. The number of what? Attributes are 20, okay? Like you see, some of the attributes are like the default, the long-term, working cash, debt cash, okay? And so on and so forth, okay? You see those attributes there, 20 of them. Gross profit, return on investment, fixed asset, okay? Okay, collateral, farm size, and so on and so forth, okay? Those are a number of what? Attributes, okay? Okay, so please take note of the fact that this is the data we are working with. That's the data we are working with. So because we had already run our model, we just went to results, and then when you click on the data, then you'll be able to do what? You'll be able to access the data. And it is also possible to export the data if you wish. It is possible to export the data out of the RapidMiner studio. Now, then you come to statistics. If you come to statistics, you can again also get the screenshot here of the statistics, and you can explain maybe briefly a few of them, just selecting a few. You know, there are quite a number. In fact, here there are 22 attributes. There's the prediction default, the confidence no, confidence yes. Okay. And you see, you are given the type, whether it is polynomial or real. Okay. Whether it is polynomial or real. Then there is the missing. If at all there is any missing values or attributes, you can see most of them is none. Okay. Then the statistics in terms of the least or the minimum, the most or the maximum, and then the values or the average. Okay. So those are some statistics which might be useful in analyzing the data. Then you come to visualizations. Okay. So this is the visualizations tab. Okay. Which is being tested in question number 7. Okay. Okay. So I'd asked you to present the screenshot of the data, which is here, the statistics and the visualizations. I think I'd asked you those 3. Okay. Then we can go back to the instructions. If we go back to the instructions, the next one is now item number 7. And item number 7 says, says that from the data visualization area, provide and explain the following plots. So hint, just click on the drop down next to the plot type and select each one of the following plot types at a time. Okay, I think that's what I've given in example in figure 6, 7, 8, 9, 10A to C, 11, and 12. I've given sample diagrams towards the end of this lab exercise. So I'm asking about the scatter or the bubble plot, the scatter or the 3D plot, the bar or column plot, the line, the step line and the spline plots, the histogram plot, and the Pareto plot. Okay. To explain them, you will have to go to the theory. We had already covered theory about data visualization. Okay, but you can also still get theory from a textbook or the internet. Okay, like the VJK textbook, you can also get the theoretical information about this. So let me illustrate number 7 before we go to number 8. So let me illustrate number 7 quickly before we go to number 8. So I can come back to the software. Like the first one there, I think I'm asking about the scatter or the bubble plot. So for the scatter or the bubble plot, you can come and under the plot, make sure that you are under visualizations. If you are under data here, you will not see anything other than the data. So make sure you first of all select the visualizations. Then you go to under plot, you go to plot type. Click this drop down. When you do that, it will give you the different plots which are available in what? In RapidMiner Studio. And make sure that you are not within the area of the map, because within the area of the map, you will only see 3 things. Huh? The choropleth map, the categorical map, and the point map. Okay. And the point what? And the point map. Okay. You see now, from this, there is very little that we can see in our case here. Okay. Okay. In our case here. Okay. So make sure that here you are under charts, because sometimes you might think that the kind of plot you want is missing simply because you had selected the maps area. Okay. Simply because you had selected the maps or the maps area. So just ensure that here you are under charts. Then when you're under charts, you now select which one you've been told to plot, like the scatter or the bubble plot. You scroll here. This is the scatter of the bubble plot. When you click on it, you'll see this is the scatter of the bubble plot. Then you can take what? You can take the screenshot, or you can just snip. Like now, this is working capital requirements. Then the long-term financing of what? Of working capital. That's the scatter plot. Blue is representing no, green is representing yes. So if you hover around blue, it will be magnified on the plot. If you hover around yes, it will be magnified on the plot. If you leave it outside, it will be presenting pairs of what? Values in blue and also in green. Okay. If you need a different plot, like another one is the scatter 3D plot. The scatter 3D plot, you come here, this is the scatter 3D plot. And so as you can see here, this one will be the scatter what? 3D plot. Then if you need, the other one is the bar or the column plot. This is the bar or the column plot. Don't confuse it with the bar or the horizontal plot, because there is also the bar or the horizontal plot. The other one is a line. If you need a line plot, is this one. This one will be the line plot. If you need the step line, this one will be the step line. Okay. And if you need, what was the other one? Is it spline? Is it spline? Yeah, spline. If you need spline, it will be this one. The other one was histogram plot. Histogram, where is histogram? Histogram is more or less, yes, histogram is here. Are you seeing the histogram? Is there. Then the last one is the Pareto plot. Click here, where is the Pareto? Pareto is here. This is the Pareto plot. Okay, that is the Pareto plot. So basically that is how we get the different visualizations. So let me ask a quick question. Are we now comfortable with the step 7 or procedure number 7 in this lab exercise? Are we comfortable with it? Are we comfortable with it?
Yes.
Okay, good. Then let's go to number 8. Click Auto Model next to the Turbo Prepper. That this is Turbo Pre-processing, and then go to select data for a new model. Samples data, then select polynomial as shown in figure 13. Click Next. You will have successfully loaded the data. Okay, so let's go to this auto model. We've told is next to the Turbo Prep. Okay, so let's go back to auto model. Are you seeing this auto model next to the Turbo Pre-processing? Click on it. When you click on it, we have clicked on the auto model. You see there is there are a number of activities which can be performed here. Load data, select task, prepare targets, select inputs, model types, then results. Okay, so we can come under select data for a new model here. Then we go to samples, double click on samples. Then we've been told to go to data, double click on data. And this is the kind of data that we were trying to access also last week. So here we've been told to select polynomial data. So select polynomial data. This polynomial data, the name is polynomial, the number of rows are 200, the number of columns are 5, and the number of specials are 1. So label or target data, the name is label, type real, mean is 180.418. The range is 0.142 to 926.739, and what is missing is nil. The attributes of the columns are, which are coefficients of the polynomial, A1, A2, A3, A4, A5. Those are 5 coefficients, which are the attributes of the columns of the data. So we've gone for the polynomial. Remember, if you had gone for a different data set, you'll also be given the information about the data. Like this market data, it says you need at least 100 rows. So this data set has only 7 rows, meaning this one will not be suitable for what we are doing here. So the fact that we've gone for the polynomial data, we've not gone for it through, I haven't selected polynomial data out of mere guesswork, no. I've selected polynomial data because I know that this kind of data will be suitable for the model that we are working with here. So after that, after selecting the polynomial data, you click next. Okay. Then when you click next, then you see we've already loaded the data. We are now at a stage where you select the task that you want to do. We can be solving a prediction problem. If you want to predict the values of a particular column, then the task will be predict. If you want to do clustering, this classification, when you want to identify groups in your data, this is a classification problem. The theory of classification we have not yet done. Theory of classification is still pending. Then you come select here. If you want to detect outliers in the data, you come select this. You had already looked at the theory of prediction and the theory of outliers. Okay. So assume, for example, that in our case, we want to do prediction. If you want to do prediction, when you click prediction, you'll be told, click on the data of the column you want to predict. So let's say that we don't know A3, and that's what we want to predict. Then you just click A3. Okay. You see, these are labels, A1, A2, A3, A4, A5. Those are labels. Huh? You can see they are label numbers. Okay. Okay. Okay, those are labels. Those are labels, okay? And the numbers associated with each of the labels are given below. If you want to predict this one, you just come and click this. If you want to predict this, you come select. If you want to predict A1, you select that. So assume, for example, or for instance, that we want to predict A3, okay? Assume, for example, that we want to predict the values of the selected column A3. That now we assume that now we don't know those values. You see those, all those values in column number 3, we assume that we don't know them, and so we want to predict them by using the values from the known columns. So if you select that, it becomes a prediction problem, which is selected here. So we say next. Then it will take us to prepare target, okay? It will take us to prepare what? To prepare target, okay? It will take us to prepare target, okay? So here, if you want to turn on classification, you check this. Then of course, we will be doing classification later on. Of course, probably not today, but when we meet on Thursday, we will do classification. You specify the number of classes you want here, okay? You specify the number of classes you want there, okay? Then the type of class building, you can specify here whether you want equal ranges or equal what sizes, okay? You can specify whether you want equal ranges or equal sizes. Then equal settings for all costs and benefits. You can define the costs for wrong predictions, okay? What is the penalty or the cost for wrong what? For wrong predictions. You can define them. You can define them here, okay? You just change you just double click and change these values for those which you want to modify. So for our case, I may choose to activate the classification or not. But you see, remember that the title of our lab exercise is also about classification, okay? So you can turn classification on here, or you can just go back and then you drop this and you come and do the clustering, because this clustering is also a classification problem. But if you are doing this, of course, you will find that you will be at liberty to either activate classification or deactivate it. For now, let me assume that I have activated classification, then I will say next. Okay. Now you will see that we've been told now to select the inputs. So you can choose here. If you don't want A2 to make a contribution, just uncheck this, okay? If you don't want the label to make contribution, just uncheck that. If you don't want, say, A1, just come and uncheck that, okay? In this case, let's assume that all the inputs are supposed to make contributions. So I've checked all of them. I've checked all of them, okay? You'll be given the corrections here, the IDness, okay? The stability, the missing, and the textness, okay? You've seen those parameters. Then you just say next. Okay. This is where you set the model types. Execution, you specify where you want the execution to take place. In this case, I want the execution by default to take place in this local machine. Okay. In what? In this local machine. So the rest will be inactive. So there's nothing that, again, you can set within the execution model, because there are usually 3 areas that you can use under the model types: the execution, the models, and the data preparation. When you come to the models, there are a number of models you can use, like the naive Bayes model, the generalized linear model. Now, let me, if suppose I deactivate or deselect the naive Bayes, because you've not been asked that, then I can select the generalized linear model. The generalized linear model, we've been told to test it both with the regularization and without regularization. If you want it to use regularization, you check this. If you don't want it to use regularization, you uncheck that. Okay. Then logistic regression is here, which you can activate or deactivate. In our case, okay, this one maybe, I'm not sure. I think maybe I did not mention about it. But if you look at the lab exercise number 1, the lab exercise number 1 was allowing you to also check the logistic regression, because actually in lab exercise number 1, what is covered there is regression. Okay. Is regression. You remember the home price data that we mentioned about last time? Yeah. So you can check this or uncheck. In this case, maybe let me uncheck it. The first margin, let me uncheck. The deep learning is required, so I can check it. The decision tree is required, so I can check it. Decision tree, you will test using 2 methods. One, with the automatically optimized tool, and then the other one without that. Okay, so you will of course check on that. The random forest, no, random forest I'm not testing. The gradient boosted trees, I'm also not testing you that in the lab. So maybe I can deactivate this. But the support vector machine, I'm asking about that. In one case with automatic optimization, meaning when you check this, and the other case is without automatic optimization. So that is what you can, that is how we make selections on the model types. Okay. Assuming you want to perform some data preparation, which is part of data wrangling and pre-processing, you can come here and select, like if you want to remove columns with too many, if you want to remove columns with if you want to remove columns with too many values, you can come check this, and then you come and specify here, okay, the maximum number of values. Okay. In this case, we've been told no columns in this data. If you want to extract data information, you check on that to extract what? Date information. Okay. In this case, it's telling us no date or time columns in what? In this data. If you want to extract text information, you check this. The automatic feature selection tool, if you want to use, you check that. Automatic feature or selection. Okay. If you want automatic feature generation, you first of all activate that, then you can come and activate this automatic feature what? Generation. Then you specify the function complexity. Do you want it to be low? Do you want it to be medium, or do you want it to be high? Then column analysis, correlations between columns if you want, importance of columns if you want, explain predictions if you want. If you don't want them, just uncheck them. Just uncheck them if you don't want them. Okay. So once you are happy with the model types part, you've set the execution model to local computer, you selected the applicable models that you want to test, maybe the data preparation here, if you're comfortable with the settings, you come and click run. Then give it time to run. So as it is running, let me revert back to theory. Let me revert back to the lab document. Okay, so here it has been said that I think I have done number 9. Under select task, try each of the following tasks and present the results. Predicting values of a selected column, say a 3 number, use predict. Identify groups in your data, use clusters. And detect outliers in your data, use the outliers block. For instance, suppose we select predict, then column number A3 as shown in figure 14, and then click what? Next. Select inputs, figure 15, and click next. We've done that. Then under models, test each of the following models, present and discuss your results. The generalized linear model with and without regularization. We had already covered regularization, which is shrinkage. Deep learning, the decision tree with and without automatic optimization, and the support vector machine with and without automatic optimization. In step number 11, using the data preparation area on the right-hand side, I think I'd already taken you there. Try data preparations through feature selection and present your results in case A in number 10 above. Maybe with what? With the generalized linear model selected. Then deploy each of the models and present your results. E.g., we can deploy generalized linear model, is shown in figure 18, and test both classification and regression. Let me go back to the model and see if the results are there. It is still running the results. It's still running the results. It's still running the results. It's still running the results. So let's give it time to continue running. The number of models so far is still 0. So let's just give it time to continue running. Okay, then this one continues and says, for each of the models, present the results after deployment under each of the following areas: model, the weights, the simulator, performance, predictions, predictions chart, and production model. For example, in the case of generalized linear model, you can see figures 19 to 24. Okay. You can see figures 19 to 24. You can see figures 19 to 24. Let me see those figures. I've given the screenshots here. Figures 19 to 24. This is figure 19A. Figure 19B, generalized linear model, the weights. Figure 19C, generalized linear model performance. And of course, this is generalized linear model, the simulator. This is generalized linear model predictions. This is a generalized linear model predictions chart. And then this is the generalized linear model production model. Let me check if the results are ready so that still running. I don't know why it is taking a lot of time. Maybe because Zoom is running, because Zoom is also resource intensive. So it is still running. But as you can see, like if you come to generalized linear model, whatever it is that you want to display, if you want to display the model, you click this. We are being told no results yet. If you want weights, you click that. Simulator, performance, feature, predictions, and the production model. So as it is running, let me switch over. To the lab exercise. So the last item would be to go to table prep area next to results to transform the data by performing a few data pre-processing activities, e.g. filter, range selection, sample, sorting. For example, select 2 or 3 columns to delete. Sort in ascending order based on selected column etc. Then run the process and capture a few results using at least 3 different plot types. Okay. Then results and discussions using the steps given under methodology section, present and discuss your results. Under conclusions and recommendations, I'm saying you give your conclusions and recommendations. Then under references, you provide me with a list of the references you have used to develop the lab practical what? Report. Let me come back here, see if the results are ready. The results are still not yet ready. They are still running. I'm not sure how long it is going to take. I didn't expect it to take much time, but now that Zoom is running, Zoom also requires plenty of resources. And I think that's part of the reason as to why it has slowed down. It will take a bit of time. But as it is running, maybe I can project something different as we wait for it to come up. So as we wait for those results to come up, as we wait for those results to come up, let me open a different presentation, not on classification, on regression, because basically regression, we had already also done regression in class, and it is also the one that we were introducing by using the sorry, something is not responding here. You give it time to respond. Okay, so as we are running the results on the other side on Rapid Miner Studio, is the projection shared on regression visible from your end? Is it visible from your end? Okay, good, good. So basically we mentioned about regression being using a function to fit data. If you have some observations or data which has been recorded about a particular scenario, you may come up with a fit for the data. It could be a straight line, could be a smooth curve, could be some other shape. If it is linear, it will be a straight line. If it is not linear, then it will just be a curve. It could be some other forms of plots. But when you attempt to fit the data into a particular model, be it a straight line model or a nonlinear model or a non-straight line model, that is what we call regression. Okay. And there are a number of empirical models which can be used to be able to sort out or solve this these problems in data science. So the empirical models are those which can be verified using experimental means. So they are not theoretical as per se. Okay, it's not that there are models which do not have got experimental foundation. No, an empirical model is one that can be verified through experiments or scientific experiments. Okay? So under the empirical models, we want to have the predictive model and the explanatory model. Under the predictive model, there is the supervised model. The supervised model, we said we use it when labeled data is available, whereby we have sets of inputs and outputs, and we want to carry out prediction. The unsupervised learning is usually used, or unsupervised training or learning, or if you are creating a model using the unsupervised learning or training approach, then we will be working with data that is not fully labeled. So unlabeled data is what is available, whereby we don't have the output, the input-output pairs. We could be having the inputs only, the input data set, but we don't have the output. So we let the model to make predictions on its own. It's not guided, okay? Or we could be having outputs, but we don't have the inputs. That's unsupervised what? Learning. Examples of problems that can be solved using unsupervised learning is the clustering and the association. Examples of supervised learning or models which can be created using supervised learning include a classification problem and the regression problem. This topic is about regression, and remember we had already done also regression, of course, in class. The main reason as to why I'm presenting this chapter is the one that supports the lab practical exercise number 1. And the lab practical exercise number 1 had already taken members through in class. The only part that was not sorted out in lab exercise number 1, which I told members to go sort out, was the issue of the data set. Okay, the data to work with, which I told you go obtain from the internet. Okay, so like now this example here, this is what we wanted to plot last time, but I was not able to locate what my data set, and I noted that creating it would have taken us a lot of time, and we didn't have that time. This is a scatter plot using the median home data set. Okay, like here is median home price in thousands, and this is the number of rooms. You see, this is a scatter plot. Now we can easily identify which kind of a plot is this. Isn't this a scatter plot? It is a scatter plot, isn't it? So if you were to do a fit here, suppose someone draws that straight line. Okay. Suppose someone draws this. Okay. That's what they are going to use for prediction. Suppose someone goes for this. Are you seeing that? I've not drawn it properly. Let me pick a rubber. Let me draw another one. Okay. Are you seeing that? Are you seeing that? Those are different what? Fits. That is the regression problem. Okay. Yeah, that's the regression problem. Okay. Yes. Okay. And this is the model. This is the model that is required to carry analysis on the median home data set. The median home data set that is given in lab practical exercise what? Number 1. You already know the function. This read CSV, you can also substitute it with the retrieve block. They do the same thing. But when you put read CSV here, it will only allow you to import data that is in Excel format. Then generate ID, I think I'd already explained that one in class. Shuffling, I'd already explained that in class. The filter example range, I'd already explained. And here we are using 2 of them in case you need 2 stages of filtering. So that is the process that we've created. Just that simple model there, okay? Then we can add to this simple model here, we can add more blocks. I want us to add 2 blocks here. Add the central block, which we are also working with in the current model, and the validation block, okay? Then they are wired the way they are here, okay? Okay. Then you'll find that now within the validation block, we said you double click it, and then inside it you put this, you put the linear regression block, okay? Under training, you put the linear regression block under training. We already know what linear regression is. Then under testing, you put the apply model block and the performance block, okay? Then you check eliminate collinear factors. And then you also check use bias. Okay. Then you run the model. Okay. Then you run the model. After running the model, because we've worked with the regression, you can go to under result history or under result. Then you will go to the model. Because the model is regression, you select regression. Then when you go to description, you will see these details. So these are the parameters which are presented in the data. The CRIM, the CZN, the INDAS, the CAS, the NOx, the RM, the A, the DICE, the RAD, the tax, and so on and so forth. Let me check if the Rapid Miner Studio is through with the execution. It is still running. It's taking a bit of time. It's taking a bit of time. It's still running, but I hope it will run. Please today, members, just be patient with me so that it finishes running. I don't want to leave that lab exercise midway because it will give you a lot of work. At least if I guide you here in class, it will minimize the time that you will spend working on it, isn't it? Is that okay? Already, of course, there are some results which are already available there. Okay, there are some results which are already available there, but they are incomplete. You see now, if you go to any more, if you go to each model, there's something that we are seeing. Like if you go to generalized linear model, under model, there's something we can see which has already been completed. The weights are there, though partially, simulator partially, performance partially, feature sets partially, predictions. Let's look at the predictions. Predictions is like most of them have been done for that tool. If you come to like now under deep learning, again, you can explore the same. If you come to decision tree, again, you can explore the same. If you come to support vector, again, the same. If you come to general here, you can view the data like I had shown before, the statistics and so on. Like if you come here under the support vector, no results yet. So it has not reached there. No results yet here. If you come to the decision tree, no results yet. It has not reached the decision tree. You come to deep learning, no results yet because it has not reached that. So the results we have so far are for the generalized linear model, okay? For the generalized linear model, that's what we have the results for the generalized linear model. So let it continue running. But as it is running, let me show you something on the model. There's something I didn't also show you on the model, of course. You see this one here under, are you seeing the apply model block? Are you seeing the apply model block?
Yes.
Yes, when you want to change the model, you just right click and then you go to replace operator. Do you see this replace operator? Then you come, the replace operator, you come, then you scroll down to modeling, because right now we are doing modeling. But if you wanted to do cleansing, you will come here. Like if you come here, if you're doing cleansing, you can do normalization, like normalized data, the normalized data scale by weights. You can come to binding, you can come to missing values, okay? And we had already looked at the different ways of dealing with missing values, like if you want to replace missing values, if you want to impute missing values, replace infinite values, and so on. You can come to duplicates here if you want to remove duplicates, outliers. You see outliers here if you want to detect outliers, and so on and so forth. Yeah, dimensionality here. Are you seeing the principal component analysis there? The first one at the top? Yes, we had already done the principal component analysis theory in class, okay? And so on and so forth. If you are doing, let's say, modeling, like for us here, we are doing modeling. If you are doing validation, you come here, like cross-validation. If you want to do cross-validation, you will select this. If you want bootstrapping validation, you select that. As we are now doing modeling, because this is a modeling problem, you can come to, if you want to do, say, optimization, you come here. Come to replace operator, modeling, then you go to optimization, parameters are there. If you want to set parameters, if you want to clone parameters, etc. Feature selection. Are you seeing the forward selection there? I'm not sure whether those pop-ups are visible. Are you seeing the forward selection there?
Yeah, yes.
Yes, the backward elimination. Those ones, the theory we had already done in class. If you want feature generation, you come here. If you want feature weighting, you come here. Automatic feature engineering, this one will do it for you automatically. You select this one. If you want unsupervised feature selection, you select that. If you want to apply feature set, you select that. If you go to predictive here, you come to predictive here, there are also quite a number. The lazy one, like there is the default model or the KNN, nearest neighbor. There's Bayesian. Under Bayesian, there are two, the naive Bayes and the naive Bayes kernel. Under trees, we will do decision trees. We will do trees in the last topic, which is on classification. You see, like now, this is decision tree. You can select them there. Like now, the decision tree is here. Random forest is also there. Gradient boost is here. Those ones are under trees. Rules, rule indication. We also do rule in the classification topic. The single rule induction, okay? The rule induction, okay? The tree to rules. How do you convert trees to rules and vice versa? The neural sets are here. Neural network, the auto machine learning processor or process, then perceptron, deep learning, okay? The functions are also here. You see functions, linear regression, polynomial regression, function fitting, vector linear regression, and so on. Like the generalized linear model is also there. Those are functions. Logistic regression, which we are doing now, like the logistic regression using the support vector machine, and so on. There are also support vector machines here, like this support vector machine, and other types of support vector machines. Okay, discriminant analysis is there. That one I haven't used before. Ensemble is also here, like if you want Bayesian boosting, transformed regression, ADA boost, okay, meta cost, and the rest. If you want to update the model, you come here and so on and so forth. If you want to create your own formula, just click here, then put that formula that you want to work with, okay? So you see that one, it can allow you to set a lot, okay? It can allow you to settle. The same way, if you come to optimize parameters here, you can come to optimize parameters here, then you come to replace what? Operator, and you'll be able to access the same things, okay? So you are able to do what? You're able to make those changes. That is also the flexibility that we have with this tool. I'm now happy to report that the execution has finished. So the execution is complete, and therefore allow me to come back to the results here. So what I was saying here, if you come to the results here, you will now see, once you finish running, like if you come, if you want the data, you will go there, okay? If you want statistics, you will go there. If you want the visualizations, you will go there. Then if you want the model, of course, you will come here. If you want the auto model, you will come. No, it had not finished, sorry. If you want the auto model, you'll come, it had not finished. I thought it had finished. It is still doing others. But of course, if it won't be able to complete, I don't want to keep you online for long because this is an online class that has got bundles. I will just, if it won't be able to finish on time, I'll just leave it. The rest you will finish, but of course I will show you maybe with one of them. This one, the generalized linear model, whose results are already what? Out. So, but the only problem is that now before this one completes, then there's a small procedure there which you may have to go through on your own. Where is it? Here, okay. So where we are now is here. Where we are now is here. Yeah, is executing that, is executing that. But I think now the rest of the steps will be straightforward. Like now, let me show number 12 using one of them. Deploy each of the models and present your results. E.g., we can deploy generalized linear model, figure 18, and test both classification and regression. For each of the models, present the results after deployment under each of the following areas: the model, the weights, the simulator, the performance, the predictions chart, and the production what? The production model, okay? So sorry, I don't know why it is taking this long, okay? When I run it and Zoom is not running, it usually doesn't take much time, It usually doesn't take much time. I don't know why it is taking much time today, because even for the deep learning, we don't have the results yet. We just have the results for the generalized linear model. But I will just use one whose results are ready, okay? Like if you want to deploy, like if you want to access the model, you come here, okay? This will be the model, generalized linear model, and the parameters. If you want weights, you come here, okay? If you want simulator, you come here. This one will allow you to access the simulator. You can always adjust that, okay? And also scroll. If you want performance, you come there. Are you seeing that? Are you seeing that? Accuracy is 5.3%. Classification error in this case is 94.7%. If you want to show costs or benefits, you click on this and you'll be given that, okay? If you want feature sets, you go there. This one is usually squeezed, right? So it's usually squeezed. Sometimes it's usually difficult to view, okay? Unfortunately, there's no way in which you can extend it. You just have to present it the way it is, okay? You just have to present it the way it is. The number of evaluated features says 336, number of generated features 56. Optimal trade-offs between complexity and error. The predictions, you come here. These are the predictions. These are what? These are the predictions. Okay, those are the predictions. Production model is here. Of course, it is still running. So if you want to deploy, you just click, do you see this deploy button? You see this one? You just come and select the model you want to deploy. Like if you select the generalized linear model, under the generalized linear model, you come and select the model there. Then maybe you click deploy. Okay. I'm not sure whether the window is visible. So you will be told here, please specify a name for this model. You may also want to add a description. So let me just call it generalized linear model. Maybe description, let me just call it JLM1. Then you click next. Okay. Then you have to choose a deployment location or create a new one if this is your first deployment. Remote deployment locations require RapidMiner Artificial Intelligence Hub and allow to integrate the model via web services, which of course you'll be required to be in the internet. So in my case here, let me use the local repository. Okay, and I say next. Okay, then select the deployments folder this model should be added to. So you can come and then maybe you select maybe like please specify a name for this deployment, must be unique as well as the model type. Like let me say GNL folder. Maybe the model type, it can be classification or regression. Okay. In this case, do you want us to select classification or regression?
Regression.
Yes, let's select regression. Then you say, okay. Okay. Sorry, there's something that it has not. Please specify a name for this deployment, must be unique as well as the model type. I don't know why it's not accepting it. Maybe GNL1. Maybe if it is not accepting to deploy, okay, and let me have that. Then you say you now click here, add model. Okay, so it will now add model to deployment. Okay, okay. I'm being warned here, low system resources may affect your audio. Okay, it's because of course I'm using what? I'm using Zoom, and this RapidMiner Studio is also a heavy software. So you can see now, we will have here, if now do you see this one here of deploy auto model? You can also have that, or you can have deploy custom model. If you come to simulator here, okay, you will access what we had before. Scoring is there. I think those are the areas, some of the areas we can view. If you want to score the data, you'll go there. So simulator, you go there. Models, you come here. Okay. If you want to deploy custom model, you click what? Deploy custom model, then you give the details. If you want to deploy auto model, you just click there. Okay. To deploy what? The auto model. So basically, members, that is how we carry out the deployment. If you want to open the process, okay, you can come here, you click open what? Process. Open process will take you to the block diagram that we started with, to the block diagram that we started with, but it will just show you the blocks that are required to create what? To create the model, and you will have to create the model on your own. You'll have to create the model on your own. But what I like about RapidMiner Studio, it will have already categorized the blocks for you. Like if you want to carry out basic pre-processing, there are these blocks which you can use, and you are told what each block does. If you want to carry out feature engineering and modeling, you have also been given the blocks that can be used for doing that. If you want to carry out transformation, or you want to transform validation and scoring data, there are these two blocks which you can use. If you want scoring, validation, explanations, and weights and simulator, there are blocks which you can use there. Production model is also here if you want to create what? Production model. So usually when you click on process or open process, it will take you to the building blocks. Okay. If of course It is still running. Yes. Are you seeing the deep learning? The deep learning one now, their results. Are you seeing the results under deep learning model? Are you seeing?
Yes.
Yes, they are there. They are there. Okay. That is for like now duration, training speed, epochs, iterations, samples training, root mean squared error training, log loss training, okay, training classification error, and so on and so forth. When you come to weights, there, simulator, okay, there, performance, there, the feature set, there, predictions there, and the production model there. If you come, let me see if the other one is also ready for the support for the decision tree. Decision tree not yet, and the support vector not yet. It's still running for those ones. So members, thank you for being patient with me. I think the rest, unless if you look at now this lab exercise, if you look at this lab exercise, I think now you should be able to manage it in the group. Okay, like this number 13, where I'm saying, go to tab of prep area next to results to transform the data by performing a few data preprocessing activities, e.g. filter, range, selection, sample, sorting. For example, select 2 or 3 columns to delete, sort in ascending order based on selected column, etc. Then run the process and capture a few results using at least 3 different plot types. I think that one again is something that you can easily do. You come to, do you see the tab of preprocessing area? This one. Yes, you come to tab of preprocessing there. Then I'm saying, then to transform the data by performing a few data preprocessing activities, e.g. filter, range, selection, and so on. So when you go there to tab of preprocessing, then you will come to, here you will have to load the data. And here we are dealing with the counterparty risk data. So you click load data, then you will find the data under samples here, under data, it is called counter what? Let me pick it from the customer credit risk data. I'm not sure whether it is the correct one. Columns 22. Okay. I hope it is the correct data. Okay. I wasn't sure about where I've selected it from, but basically, you will definitely have to load the data that here I've called it customer credit risk data. I'm not sure whether it is the same as the data that I was looking at. This one is under data which is under training resources. Yeah, this is the one. Okay, this is the one I've loaded. Okay, customer risk data. Okay, but this one, of course, is about the Titanic accident. I don't know where the data has gone to. But what I wanted is we access the data. There is a place that I was supposed to be taken to. I don't know why I haven't been taken there. These areas are usually quite many. Yeah, it's here under templates. It's under templates. So credit risk modeling here. Yes, the counterparty risk data. Then now you select it. Then after selecting it, you can import the data. Okay. You can, okay. You can import the data. So this is the counter risk data. Then the tab of preprocessor is a data preprocessing and wrangling tool. So it can allow you to, like, if you want to transform, okay, you will maybe, for example, have a range there, you specify, then you apply, okay? You specify, then you apply. If you want to sample, you will give the sample number, okay, or the sample percentage, then you specify in value. Like if it is sample percentage and you want maybe just 80% of the data, you apply. It will select for you automatically. Then commit transformation, meaning you want to apply, then you do that. Are you seeing now how this tool does the processing, the data pre-processing automatically for you? If you want to cleanse, you just come here. Auto cleansing, remove low quality, remove correlated. Like if you want to remove correlated, you say apply. If you want to remove low quality, you say apply. No columns have been selected. So you have to select which column you want to do it. You want to remove the low quality data from. Auto cleansing, okay, click on the data of the column you want to predict later on, or hit the above word, or hit the button above, okay? So you'll have to select the column and then you say next. If you do want to keep the original, or you want to change all the numbers or change all the categories, okay? Okay, and then of course you'll say what? You say, now, perform principal component analysis, which we had already done. If you want, you check that. The principal component analysis, we had already looked at that. Then if you want to perform normalization, you also check that, and then you say next. Okay. Then like now, target column, debt cash flow coverage ratio, remove low quality columns, replace missing values, perform principal component analysis, and perform normalization. So if you are happy with these choices, you say apply auto cleansing. Okay. Then after you have applied that, you click on commit cleanse and it's applied. If you want to use generate, the same way you come to generate. If you want to use pivot, you come. If you want to match, if you want to use the model, I think I'd already shown you this one of modeling, okay, and so on and so forth. Okay, so I think is that clear? Is that clear? Sorry, by going to that one, it had aborted what we were doing, but at least I wanted to get to there and show you that so that we can stop, and thank you for being patient with me. So I would want us to stop there in terms of the theory. This one that I was introducing, we will continue with it. This one, I had gone up to the linear regression part. I will still, of course, highlight a few things here next time we meet, but the content that is here is not new, okay? But you should do it in lab practical exercise number 1. These are some of the These are some of the results you will get from lab practical exercise number 1. So this presentation is just meant to help you maybe with the theory that you might need to compare with the kind of results you will get from what? The kind of results you will get from the lab practical exercise number 1. And I would expect these lab practical exercises to be submitted very soon. Remember, examinations are around the corners. I don't want members to keep these lab practical exercises. I don't want members to keep what? These lab practical exercises. So unless if there are questions, thank you members for creating this time. Apologies for the technicalities around Zoom that made us to start late. Unless if there are questions, I would want us to stop there. Is there any question or we stop? Is there any question or we stop? We can stop, isn't it? Just make sure that you have registered your presence on the chat area there. So I have some questions there. When is the submission deadline? I think for lab practical exercise number 1, number 2, and number 3, I will extend the submission deadline to Monday next week by midnight. Monday next week by midnight. We'll do that. And remember, it's group work. But group members who are not participating, don't put their name on the work so that they score 0. And they should not bother me, because group work, if you don't participate in group work, you just score 0, and you can't be given your own assignment and this group work. So you just score 0 and we proceed. Okay. Whoever is not participating, let the group leaders give me that information. And if the group leaders don't give me that information, at least I will also have to use my own means to find out group members who are burdening their colleagues, that they don't want to participate in group work, and it's only a few members who are doing the whole work. They will not get marks from the sweat of their colleagues. Okay, they will definitely have to carry their own word crosses. Good. So thank you for that. I had already announced cut 2 and the final cut next week, Thursday. And then of course, this week, Thursday, we will meet from 3 p.m. as usual. Thank you very much. Bye for now, members. Enjoy the rest of your evening.